Dear students, Assalamu alaikum and welcome to the 12th program on software engineering. Dear students, in previous few programs we discussed the requirements gathering and analysis phase of software engineering. We described various techniques that may be useful in collecting user requirements. There is of course little doubt that if as a software engineer you fail to completely and correctly elaborate user requirements, there are no chances to successfully complete the software project. Recall that one has to prepare a number of models during the analysis phase. These models are very useful to understand the working of the system as well as understanding the user requirements for the system to be designed and developed. The common models that are developed in traditional software development process, that is structured system analysis and design, are shown in this slide. These include data dictionary, entity relationship diagram, data object description, data flow diagram and process specification, state transition diagram and control specifications. Dear students, of course, different methodologies are used to prepare different models. For example, if you are using object-oriented approach, you might be using UML to develop class hierarchical diagrams and use cases. Therefore, we urge you to look at various models that are developed while you are using a specific methodology. There are a number of books available to develop these models. We explain to you how these models are prepared with the help of sample examples. The purpose was to introduce to you various concepts and symbols that are used in a particular model. In today's program, we will present a case study and develop various models based on this case study. Let us start by having a look at a brief description of the system. The university is planning to offer an online testing system for number of courses at both basic and advanced levels. System description and requirements were obtained after having a number of interviews with the stakeholders, that are registration office, teachers, students and other stakeholders. By looking at the similar systems and various documents that were available with the university. A brainstorming session with a team of software experts, faculty members and university administration was also arranged. Here, you must realize the use of different requirement elicitation techniques. Dear students, now let us briefly look at the requirements of the system. Let us have a look at the brief description of the system. A distance education university is planning to offer an online testing system for a number of courses both at basic and advanced levels. It is planned that the university will arrange these tests 3 times every year for each course. The date and time for each test will be fixed by the registration office, and students will be required to attend a test on a particular date and time for which they register themselves. Each test will be identified by a unique test number. These tests may be of different durations. It is also decided that all the tests will comprise of multiple choice questions, and a student will have to select the correct answer for each question. The tests will be prepared by a group of university teachers who will not only prepare questions but also provide their correct answers. Before taking a test, the student must enroll the course. Student personal information is also required. Student will be allocated a unique ID based on a personal information. The ID can be used to register for the test. When a student is registered for the test, the registration date should be recorded. Student is allowed to register for one or more tests at the same time. Test start time, finish time and answers should also be recorded. At the completion of a test, the system should do grading of the student. Result of a student is communicated to him via his or her email address. A certificate bearing unique number, date of issue, along with other information such as student ID, name and course information is issued to the successful student. These were some of the descriptions of the system. Now let us see the requirements of the system. The system should allow a new student to enroll with the university. It should allow the enrolled students to register for a particular test. The system should have ability to store multiple choice questions with their correct answers. The system should have an online facility to allow a student to submit his answers. It should automatically calculate the grade of students. It should provide the facility for sending the results to students via their emails. The system should print certificates for all successful students. It should be also capable of printing the list of students registered for a test. The system should be able to print results of all the students registered for a particular test. Dear students, can you think of other requirements for such a system? Yes, the answer is there can be many other requirements for such a system which we may have overlooked. But we would recommend you to not to go outside the boundaries of the system. This description is not complete in all respects and there are many information gaps. Nevertheless, it is a good starting point. We have intentionally left out some of the information and you will notice them while modeling. Also, note that modeling is an iterative process. You start developing a model and when you discover some missing information and anomalies, you will have to resolve them. Dear students, before proceeding to the next slides, let us have a look at the non-functional requirements of this system. These can be system security, the technology to be used to develop this system, and the time constraints, the reliability requirement for this system, interface design that may include selection of fonts and colors, and there are many other non-functional requirements that may arise during this process. Some of these requirements may become functional if decided. Our system provided requirements definition only. Your activity is to develop requirement specification, that is detailed description of each requirement definition. Let us now develop a data model. We will do this by developing an ER diagram, which is a simple yet powerful tool to capture the data requirements of a system. The first step in developing an ER model is to look at the system description and find out the entity types. In our system, the entity types are highlighted in red color. The entities include course, test, student, question, answer, teacher, and student answer, and the certificate. Dear students, once we have identified the entities in our system, we look for the attributes of each entity and identify the primary key for each entity. Then look for the relationship type between different entity types and constraints on those relationships. That is to determine whether the relationship is one-to-one, one to many or many to many. Also determine the participation constraints, that is, determine participation of an entity in a relationship is optional or mandatory. Remember, participation of an entity is optional if an entity can exist without taking part in a relation. For example, can we have a student in the university, but he has not registered for a course? If organization rules allows it, then you may consider the student entity has an optional participation in the relationship, course taken. Otherwise, it will be mandatory. This table shows the outcome of our exercise. This table shows the outcome of our exercise. The entities are listed in the first row and in the first column. Their relationships are mentioned in the table. For example, the student certificate and course has a ternary relationship. One student may be enrolled in a course and he may get a certificate. Likewise, many students can be enrolled in many courses and they can get many certificates for each course. A student can sit in a test, or many students can sit in many tests. A student gives answers to many questions, or many students can give answers to many questions. Similarly, all the relationships are given in this table. Now, we can develop an ER diagram by using the information we extracted from the system description and our understanding of the system. The ER diagram for our system may look like this. A student can get a course and can get many certificates against this course, or many students can get many courses and get many certificates in many courses. The student can sit in a test which contains questions that are prepared by a teacher. The student answers questions and he may answer one question or more than one questions. Similarly, more students can answer more questions. It is also very useful to write a description of each entity, attribute and relationship. This description will provide additional information about entities, attributes and relationships. For example, you should be describing each entity type, each attribute, that is its alternate name, its type and its domain. Dear students, now let us see how to do process modeling. For process modeling, you need to go back to the description and look for what the system does. We start process or functional modeling by first constructing context level diagram. You should look for external entities first, that is, who supplies what data and receives what information from the system. This step generally involves some hard work. You might not be able to get all that information from an incomplete system description, as is the case with our description. The system analyst has to discuss with the stakeholders to really find out what information they expect to receive from the system and what data is required from them. This might need starting with a basic context level diagram and then refining it until we capture all the data flow to and from the system. That is, process modeling, like data modeling, is highly iterative process. Let's see what are our external entities and information they receive or provide to the system. Using this information, we construct context level diagram which looks like this. Here we have entities student, teacher and registration office, and the system is marked with 0. These entities provide some information to the system, and this system provides information to different entities. Dear students, at this level the whole system is shown as a single process. The entities and the information they provide and receive from the system are also shown here. Once a context level diagram has been developed, we need to develop level 0 DFT. At this level, you should identify the major functions, activities and subsystems of the system you are modeling. In our example, if we read the description of the system, we note that our system performs 4 major activities. They are managing registration of new students and students registration in particular tests. The second activity is managing tests, that is recording test questions, correct answers, delivering test questions to registered students on the day and time of tests and recording the student answers, etc. The third activity is allowing registration department to provide or change course list and test schedules. And finally, producing various reports for the registration department and distribution of grades to the students. From this information, we can build our level 0 DFT, which will look like this. Here we have 4 processes, as we have already mentioned: manage student registration, manage tests, produce reports and manage course test schedule. These processes get some information from different entities and they may store these information. For example, we have personal information of the student, and this process stores this information into the student file. Similarly, the produce reports process gets information from test registration file and sends grade certification information to the students. The next step is to take each process at level 0 and expand it or create its child diagrams giving more details about that process. This becomes the process of creating level 1 DFD from the level 0 DFD. Here we have level 1 DFD for student registration process. It includes 2 sub processes, which is 1.1 and 1.2. This process enrolls new student and sends student information to the student file. The manage test registration process gets test schedule from the test file, gets ID and registration information from the system and other information about the student into the registration file. The next step is to take each process at level 0 and expand it or create its child diagrams giving more detail about that process. For example, manage student registration is the process number 1 at level 0 DFD. We will expand this process into its sub processes. Here we have 1.1, that is enroll new students. This process will get personal information from the student and send back to the student his ID or her ID confirmation. This information is stored into the student file. The second process is manage test registration. This will get data from the student file and ID and registration information from the student, and this will get registration. The second process is manage test registration. This will get information from the student in the form of student ID and test he or she wants to enroll for the course. Similarly, the level 2 DFDs for this process are shown here. It gets student ID in the sub process number 1.2.1. Then the process 1.2.2 validates the student ID by confirming the student file. When the student ID is validated, the process gets test registration request. This is sent for validation to the test registration process, which gets test schedule from the test schedule file and sends this information to the update test registration file process. This process gets student ID and test registration information from test registration file. The update registration file updates successful information and sends it to the send confirmation process, which sends the information to the student. You can build level 1 DFDs for other processes in a similar fashion. The processes in level 1 DFD can be further expanded until each process becomes simple enough that a process algorithm can describe it. Here, level 1 DFD for another process is given. It has sub-processes record test questions, record correct answers, send test questions, and record student answers. Then there is another process which performs the grading of the student. Different information flows from one process to another process or data store. Dear students, once we have completed the DFDs, we need to write the process description, that is P-specs for each the process that does not have any child DFD. You can write P-specs either using an English-like algorithmic language or a more formal PDL. Some examples of P-specs are given here, and the details of this activity has been left out for students for their practice. These P-specs are given on this slide. In today's program, we presented a case study. We discussed system description and requirements of this system and developed various models based on this case study. Till the next program, thank you and Allah Hafiz.